Namaste, this is BSc B.Ed second semester class of State of Matter, and today our topic is acid base. So first of all, we discuss here the first theory of acid base, that is RNS theory of acid base. According to this theory, acids are substance which produces hydrogen ion in the solution, and bases are substance which produces hydroxide ions in solution. So neutralization happens because hydrogen ions and hydroxide ions react to produce water. Now the limitations of the theory is hydrochloric acid is neutralized by both sodium hydroxide solution and ammonium solution. In both cases you get a colorless solution which you can crystallize to get a white salt, either sodium chloride or ammonium chloride. These are clearly very similar reactions. The full equations are discussed here, right here. You can see in the hydroxide, in sodium hydroxide case, hydrogen ions from the acid are reacting both hydroxide ions from the sodium hydroxide. So in the ammonium case, there don't appear to be any hydroxide ion. But if you look at the equations carefully, the ammonium is in solution. Ammonia react with water like this. This is a reversible reaction, and in a typical dilute ammonium solution, about 99% of the ammonia remains as ammonia molecules. Nevertheless, there are hydroxide ions there, and those react with hydrogen ions in just the same way as hydroxide ions from sodium hydroxide. So you can just justify ammonia as being a base on the RNase definition. It does produce hydroxide ions in solution. But most of the reactions is going to be a direct reaction between ammonia molecules and hydrogen ions, which doesn't fit the RNase definition. So this is the limitation of RNase theory. Now the next theory is Bronsted-Lowry theory of acid base. According to this theory, an acid is a proton donor and base is a proton acceptor. This is the relation between Bronsted-Lowry theory and RNase theory. The Bronsted-Lowry theory doesn't go against the RNase theory in any way. It just adds to it. Hydroxide ions are still bases because they accept hydrogen ions from acids and form water. An acid produces hydrogen ion in solution because it reacts with the water molecules by giving a proton to them. When hydrogen chloride was gas dissolved in water to produce hydrochloric acid, the hydrogen chloride molecules give a proton to a water molecule. A coordinate bond is formed between one of the lone pair on the oxygen and hydrogen from the hydrochloride. Hydroxonium ions H3O plus are produced. You can see the reactions. So when an acid in solution reacts with a base, what is actually functioning as the acid is the hydroxonium ion. For example, a proton is transferred from the hydroxonium ion to a hydroxide ion to make water. So it is important to realize that whenever you talk about hydrogen ion in solution H plus, what you are actually talking about hydroxonium ion. So this is Bronsted-Lowry theory and conjugated pairs. What is conjugated pairs? According to this theory, when hydrogen chloride dissolved in water, almost 100% of it react with the water to produce hydroxonium ion and chloride ion. Hydrogen chloride is a strong acid, and we tend to write as in one way reaction. You can see the reaction. In fact, the reaction between HCl and water is reversible, but only to a very minor extent. In order to generalize, consider an acid HA and think of reacting of being reversible. Thinking about the forward reaction, the Ha is an acid because it is donating a proton to the water, and the water is a base because it is accepting a proton from Ha. But there is also a back reaction between the hydroxonium ion and A minus ion. The hydroxonium ion is an acid because it is donating proton, and A minus ion is a base because it is accepting a proton from hydroxonium ion. So in this reversible reaction contain two acids and two bases. We think of them in pairs called conjugated pairs. When an acid Ha loses a proton, it forms a base A minus, and when a base accepts an proton back again, it is obviously reform an acid Ha. These are two conjugated pairs. So this is about conjugated pairs. A second example of conjugated pairs you can see in this reaction, where ammonia reacts with water and forms ammonium ion and OH minus ions. So ammonia and ammonium ion are conjugated pair, and H2O water and hydroxyl ions are conjugated pair, where in this conjugated pair, one is acid and one is base, one is proton acceptor and one is a proton donor. Now we discuss about amphoteric substances. You may possibly have noticed that in one of the last two examples, water one was acting as a base, whereas in the other one it was acting as an acid. A substance which can act as either an acid or a base is described as being amphoteric. Now the next theory is Lewis theory of acid base. According to this theory, an acid is an electron pair acceptor and base is an electron pair donor. Lewis bases. It is easiest to see the relationship by looking at exactly what Bronsted-Lowry bases do when they accept hydrogen ions. Their Bronsted-Lowry bases we have looked at are hydroxide ion, ammonia and water. They are typical of all the rest. The Bronsted-Lowry theory says that they are acting as bases because they are combining with hydrogen ions. The reason they are combining with hydrogen ions is that they have lone pair of electrons, which is what the Lewis theory says, that two are entirely consistent. So this extent the concept of a base at the moment it is from different angle. So the other similar reaction of ammonia and water, for example, you can see in this reaction. Now we discuss about Lewis acid. Lewis acids are electron pair acceptor. In the above example, the BF3 is acting as a Lewis acid by accepting in the nitrogen's lone pair. The Bronsted-Lowry theory, the BF3 has nothing remotely acidic about it. This is an extension of the term acid well beyond any common use. Obviously, acid-base reaction, like for example the reaction between ammonia and hydrogen chloride gas, what exactly is accepting the lone pair of electrons on the nitrogen. So you can see in this reaction that ammonia and ammonia plus HCl react and forms ammonium ion and Cl minus ion. So chlorine is more electronegatively than hydrogen, and that means that the hydrogen chloride will be a polar molecule. The electrons in the hydrogen chlorine bond will be attracted towards the chlorine end, leaving the hydrogen slightly positive and the chlorine slightly negative. The lone pair on the nitrogen of an ammonia molecule is attracted to the slightly positive hydrogen atom in the HCl. As it approaches it, and the electrons in the hydrogen chlorine bond are repelled still further towards the chlorine. Eventually, a coordinate bond is formed between the nitrogen and the hydrogen, and the chlorine breaks away as a chloride ion. This is using the curly arrow notation commonly used in organic reaction mechanics. You can see in this reaction. So this is about Lewis theory. Thank you so much.